All right, welcome to our lesson video for Chapter 4, Lesson 1 over classifying triangles. I'll try and keep this pretty short because you, as good students, have already done your vocab, and so you are going to recognize these words right away and know what they mean, and so we're going to move right on in. In the past, we've measured and classified angles. Well, we're going to use some of that now and focus on identifying and classifying triangles by their angle measure. That's one way we can classify triangles. But you can also identify and classify triangles by their side measures, their side lengths. So we'll talk about that in this lesson also. So here's a brief rundown of all of our new vocabulary. We will be talking about acute triangles, equiangular triangles, and that's kind of a new concept, but it really is a new way of describing an old concept. We'll talk about obtuse triangles, right triangles, and then also equilateral, isosceles, and scalene triangles. Again, these vocab words should be in your vocab notebook. And so let's break down the two types of classifications. Triangles can either be classified by their angles or by their sides, actually, and by their sides. It's possible and entirely likely that we will have triangles that have two classifications. Every triangle can in fact have two classifications. So first let's talk about angle classifications. We have what's called an acute triangle, which means that all three angles measure in acute measurements. All measures are less than 60 degrees. Remember, acute means less than 60. All right. Then equiangular really just means equal angles. Okay, it means that all three angles are congruent. Okay, and if it's equiangular, we're going to look at later on the fact that it is also equilateral, which is the triangle you're familiar with classifying. But then, if we call it an obtuse triangle, that means there is exactly one obtuse angle, and it could also be a right triangle in which there is exactly one right angle. You cannot have two obtuse angles, you cannot have two right angles for it to still be a triangle. All right? But then we also can classify by sides. So if all three sides are congruent or of equal length, we call it equilateral. If we have at least two congruent sides, then it's isosceles. So here's my question. If all three are congruent, does that mean at least two are congruent? Hopefully you're making some kind of an answer, otherwise I'm asking a question for no reason. But the answer is yes. If three are congruent, that is at least two. So equilateral triangles are always isosceles as well. But not all isosceles are equilateral. And then we have what's called a scalene triangle, in which there are no congruent sides. They're all three of different measurements. Okay? So, example 1 is going to ask us to classify based on angle measure. These are all angle measurements. So, example 1 is angle classification only. And that's why we are only given angle measures and not side lengths. So, in this example, we have angle measures of 70, 70, and 40. Since all three of those numbers are less than 90 degrees, and I just realized I made a mistake. Hopefully we can go back. I said acute angles are less than 60. I was wrong. Acute angles are less than 90. Let's get that fixed. Oops. All right, so since all of these are less than 90, this is an acute triangle. And in this example, we have one 90-degree angle, which makes it a right angle. That means it is a right triangle. And then over here we have 49, 34, and 97, so that is obtuse. Since there is one obtuse angle, it's an obtuse triangle. And a lot of times I will not be writing the word triangle, I will just use a triangle as our symbol. All right. Why don't you try and classify these? Now, pay attention. Here we actually have three distinct triangles. We can talk about triangle PQR, which is the bigger triangle, triangle PQS, and triangle, oops, not A, triangle QSR. I want you to classify all three of those from that one diagram. Pause the video if you need some more time. Otherwise, These are the answers you should get. Since all three angles are the same measurement, they're all 60 degrees, this is technically acute because they're all less than 90, but the more descriptive classification is equiangular. All right. Now for the three triangles here. Let's start off with one of the obvious ones. QSR has a right angle, and so angle QS, triangle QSR is a right triangle. Then we have the other smaller triangle, PQS. This is also a right angle, so it is also right. And then their total, you would have to add these two measurements together. 45 plus 59 is 104 degrees total, which is greater than 90, so triangle PQR is obtuse. All right, let's go ahead and take a look at the next example then, speeding right along. Example 2, if M is the midpoint, I'll bring back a concept from chapters 1 and 2. If M is the midpoint of segment JL, we should be able to classify these. Now, if I'm talking about equilateral, isosceles, or scalene, I am using side classifications or side length classifications. And so equilateral, isosceles, or scalene, equilateral means that they are all congruent. 3 congruent sides. Isosceles is at least 2 congruent sides. And scalene, all different side lengths. All right, so let's look at triangles MLK, JKM, and KJL. All right, now we know M is the midpoint of JL. It's given to me that way in the problem. That means that ML should be also congruent to JM, so I'm going to mark that one congruent with these other ones. All right, and since they give me the total length, I can actually cut that in half and find out what each of those is. If I did 1.5 divided by 2, I can get what each of these segments is. Half of 1.5 is 0.75. So JM is 0.75 and ML is 0.75, but those are congruent to KM, so that's also 0.75. So let's take a look here. We have triangle MLK. MLK is this triangle here. We have 2 congruent sides and a third side that's different, but because there are at least 2 congruent sides, it is isosceles. And then let's look at triangle JKM. We have these 2 sides congruent as 0.75, but you are also given that KJ is 0.75, so all 3 sides are the same length, and so it is equilateral. And then lastly, triangle KJL. KJL altogether. We have a side length of 0.75, 1.5, and 1.3. All 3 of those are different measurements, so this is a scalene triangle. All right, let's move right along to example 3. This deals with finding measurements given these algebraic expressions and a specific kind of triangle that it is. So in example 3, we are told that triangle ABC is isosceles. That means there are 2 congruent sides, which they have marked for you here and here. So to find the measure of all 3 sides, we have to know what x is. But because of this relationship, we know that AC and BC are congruent. And if AC is congruent to BC, the length of AC equals the length of BC, which means their expressions, 4x plus 1 and 5x minus 0.5, are equal also. So in order to find the value of x, to find these different lengths, I'm going to solve that equation for x. And I'm actually going to let you pause the video to do that yourself. You should be pretty good at solving equations by now. When you are ready, continue watching. If you need more time, push pause. Otherwise, here we go. So if we subtract 4x from both sides and then get x by itself, we get this. X is 1.5. So I should be able to plug 1.5 in for each side and get a total. When I plug in 1.5 here, I'm going to do 4 times 1.5 and then add 1. 4 times 1.5 is 6, and then I add 1 to get 7. So AC is 7. BC we've said is congruent to that, so that will also be 7. If you want to check it, we do 5 times 1.5 and then subtract 0.5. 5 times 1.5 is 7.5 and subtract 0.5. Hey, that's 7 again. And then for AB, we do 9 times 1.5 and then subtract 1, which is 12.5. So the length of AB is 12.5. And so all three of these are your answers. All right, that leads us to one final example in lesson 1. Again, we're dealing with a triangle that we have some varying side lengths, and it would appear that this is a scalene triangle, but we're going to figure that out for ourselves. If the perimeter is 47, we should be able to find x. Remember that to find the perimeter of a triangle, that's the sum, write a little more clearly, sum of all the side lengths. And so we're just going to add all these up to set them equal to 47. This is the equation we should set up. 2x plus 6 plus another side, x plus 3, plus the third side, 3x plus 8, equals our total perimeter of 47. Now, you could do it that way, or you could combine all your like terms as you go and jump straight to this equation. (6x plus 17) equals 47. Again, we just combined like terms to get that. And so then we proceed to solve for x. You guys should be able to do that. We should get this. X equals 5. And that's all we were supposed to find for this. Oh, I'm sorry, I got going too fast. We do want to find the length of each. So what you need to do is plug in 5 for x in each of these cases to find the differing side lengths. All right, if you need time to be able to do that, go ahead and pause the video. Otherwise, these are what we should get for our side lengths. 16, 8, and 23. So those are your three side lengths, which would make it scalene, because all three sides are different. And we got that because x was 5. All right, that concludes our video. Kept it a little bit shorter, hopefully a little more interesting, but covered all the examples. Remember, you do need to complete these notes, the vocab for lesson 4.1 and the 4.1 practice assignment. All of those have been attached to the Edmodo post where you found this video. So if you need any more help, come in early Monday morning. Otherwise, we will get to this in class.